Hi friends, very good evening and thank you for joining in. Could you please confirm in the chat window if I am visible and audible so that we can get started with today's session in a few minutes. Can you just confirm that? Hey, good evening everyone. Thank you for joining in. Let me just check on my own phone if everything is working as expected. Yeah, I don't see any glitches from my side. Yeah, so good. Okay, we'll start in about 4-5 minutes. In the meantime, I can take a couple of questions, general questions, and I'll answer other general questions at the very end. Right. So if there is any question, I'll try to tackle a couple of them before today's session. And as usual, we'll answer some general questions at the very end. So feel free to type them in the chat window. So Yash has a very nice question. So Yash says, should I look at the rank or the marks while attempting practice tests? So Yash, in your first iteration, don't worry so much about the rank. Worry mostly about the marks that you're getting. You should ideally try and get about 40% marks. I mean, if you get 40%, you're on the right track. If you get less than 40%, we recommend that you go back, watch the videos, fill the gaps, understand why you're making these mistakes, and then retake. Especially answer those questions which you got incorrectly. That's what we recommend. Even if you get 70% or 80% marks, all those questions that you got answers incorrectly, don't look at the solution right away. Try to give it one more shot, maybe a few hours later. Try to see if you can fix your problem. If you're not able to solve it and fix the mistakes that you've done, it's always better to go back and see what your conceptual gaps are and fill that. That's a standard recommendation for practice tests. How to keep up with the iterative process of revision? It's very simple, right, Dipyan? The way we recommend, the way which also works a lot for students is they have fixed hours every week. So we have students who say, hey, every Sunday between 4 to 7 p.m. we just block that time. We revise everything that we learn that we learned in the last week. Similarly, last 2 days of a month. Let's take this month, right? 29th, 30th. Some students we also recommend this to students. 2 days they completely block it. They try to revise everything that they learned in the month, and so on and so forth, right? So it's as long as you're disciplined with it. So just remember, in your first iteration, the revision should be every week, every month, every quarter, or every 3 months. Simple logic. That'll streamline everything else. When will we start giving test series? So Gurpreet, for the test series, our recommendation is this, that whenever you finish a subject, try and answer questions. After, let's assume you prepared for a subject. If you're a test series enrolled student, take the topic tests and the subject test for that subject. Once you finish 2 or 3 subjects, try and take the multi-subject tests. Once you finish the whole syllabus, revise everything once, start taking the grand tests and mock tests. That's what we recommend. If you're a course enrolled student, you also have the last year test series accessible to you. So you have literally double the questions along with practice questions and solved problems and all of that stuff. So you have literally like almost 2.5 times more questions as a course enrolled student. So, but the logic stays the same. Once you finish a subject, take topic tests, take subject tests. Once you finish 2 or 3 subjects, take multi-subject tests. Once you finish everything, go take your grand tests. So to put it in context, right? In your weekly revisions, you can take topic tests. In your monthly revisions, take subject tests. In your quarterly revision, take multi-subject tests. That's how we've designed the whole program itself. And once you finish everything, once you finish the first iteration, revise everything, start taking grand tests, keep filling your gaps, keep correcting your mistakes. That's the strategy. Cool. Again, this is Kiran. Kiran says, I'm currently working with pointers in C. I'm feeling low and very confused because it feels hard. So Kiran, my suggestion to you is simple. Again, you may have seen this in our course videos. You may have seen this in the live sessions that we do. Whenever there is a pointer problem, understand what type of pointer is it. Is it an array of pointers or a pointer to an array? That is the most confusing and tricky part. Again, we have solved some problems in the live session on the specific thing. Always draw diagrams. Say, okay, this is where my pointer is stored. This is pointing to this. It is diagrams which will simplify things for you. Get into that habit of drawing the pointer diagram, saying, hey, here is my memory location. I have a pointer variable here. It is pointing to this. And if I increment it, what should happen? So the easiest way, this is how I solve it. This is how a lot of our mentors also solve, which is they draw diagrams. That's why even in the course videos or in the solved problems and in live sessions like this, we always try to draw diagrams, because it's easier for students to connect and solve problems themselves later on. So Bapi says, which book should I follow for DS and algorithms other than Corman? I think you don't require to follow any other book apart from Corman, Leisers and Riverstein's Introduction to Algorithms. That's more than enough for, again, remember, this was a standard textbook even during my MTech days when we took a algorithms course at graduate level. So this book is so good that it covers whole of undergraduate and graduate level data structures and algorithms. Of course, it doesn't have some of the advanced randomized and approximate algorithms. For that, there are other textbooks, but it's a pretty good book, more than sufficient. We often tell that somebody who can solve even 50% of the problems in that, they can crack Google or any other top company very, very easily if they can translate that solutions to code. So it's such a brilliant book, more than sufficient. You don't have to think of anything else apart from Corman Leeserson's textbook. So Abhinav says how to manage gate and placement prep. Again, the strategy there is simple. The reason we have moved some of these subjects like data structures, algorithms, programming little ahead and moved subjects like engineering, math, we have reordered the subjects slightly because you'll have placement season in the next couple of months. So if you have placements around the corner, try and focus on programming, data structures, algorithms, because the skills are the same. Please remember that. There is significant overlap in skills. So my suggestion is, please practice data structures, algorithms, programming in C or any language of your choice. Once the placement season is over, get back to other subjects. Again, it will be good if you can also prepare a little bit of operating systems, especially SQL, and maybe basic concepts of semaphores and deadlocks in operating systems, because they're also very commonly asked questions in general. So in some technical companies. So if you just prioritize these topics and these subjects during your placement season, I think it's easy to manage. Because once your placement season is over, you still have a few months for your gate prep. So where should I practice competitive coding? Again, there are literally hundreds of platforms now. I personally like LeetCode. I like it a lot personally because everybody has their own preferences. I like LeetCode because of the simple interface. Very easy to participate in things. So I personally like LeetCode, but I also know people who love other platforms. There are literally hundreds of them. Pick any one, it's okay. Pick any one that you're comfortable with. Try to solve. Start with easy problems, then go to medium, then go to hard. What I also like in LeetCode is the structure is very neat. If you want top product-based companies, go do medium and hard. If you want services companies, I think easy should be okay. And in between product-based startups is easy and medium, right? So that's a very clean structure. I like LeetCode personally, but it's just a personal choice. I mean, you will not go wrong if you pick any other coding platform. There's nothing wrong with any of them. They're all good. It's just a personal choice. Do I need to learn set theory first before learning DBMS? Adarsh, the way we have created our content is we try to decouple the subject so that students can cover subjects in any order. So, for example, let's take when we discuss in database management systems, relational algebra, all we are assuming is that you know a little bit of set theory from your high school days. That's all. Everything else will cover it there. And some of that will also be covered in set theory in engineering math. So there is some overlap. Similarly, in digital logic design, we cover Boolean algebra. Same Boolean algebra you'll also see from a mathematical standpoint in engineering math and discrete math. Similarly, graphs, we don't have a specific order because we believe that students can pick any order. So some concepts of graphs are covered in engineering math from a math standpoint, and the same concepts are again covered in data structures and algorithms from an algorithmic standpoint. So the way we have created most of the content is such that students can pick any subject and understand most of it. The only assumption we are making is you remember a little bit of your 9th and 10th class math, like what is a set, what is union, what is intersection. If you remember that, that's basic high school math, right? You'll be able to understand most of DB, because whatever is needed, like what is a cross product, we cover that in detail with examples, with diagrams and things like that. So you don't have to worry about it. Cool. So Thakur is asking about problem sessions. Again, you can just go to, okay, so you can just go to the sheet that we have. It'll be good if one of the mentors can just place it as a comment and tag it or pin it as a top comment. So we have a series of live sessions. Some of them will be public, some of them will be private only for our course enrolled students. Right now we are doing a lot of data structures, algorithms and C programming publicly, because we hope that it will benefit some of the non-course enrolled students also. The other live sessions, once we finish data structures and algorithms by mid-July, you will have some public sessions, some private sessions. Okay. Anyway, so let's just go into our actual live session. It's 7:07. Okay, I'm just changing to my screen. Can you please confirm if my screen is visible and if I'm audible clearly? So can you just confirm that, so that we'll get started with today's session. Cool, very good. Okay, so a quick update on things. Today's topic is time complexity. Again, we see time complexity in lots of places in data structures and algorithms. So in this session, we'll be asking a few easy questions and maybe a couple of medium questions. But remember that we'll again encounter time complexity in the next sessions. We have another 4 or 5 sessions for, if I'm not wrong, I think we have 7 live sessions for data structures and algorithms. So we have another 5 live sessions, all of them publicly available, in which we will keep revisiting time complexity. Here we are only going to cover it in the limited context of what we have covered, like sorting algorithms and the core time complexity questions. Oftentimes in GATE, you will encounter time complexity questions in the context of other data structures and algorithms also. So we will see those questions in the future. So the scope of it will be limited because we have just done sorting and searching algorithms in the last live session. And this live session is time complexity. Again, this is one of the most important and useful topics in general. This is such a generic topic that even if you're applying for machine learning data science roles, you're expected to know the basics of time complexity. It is, if you're in any computing related role, I think time complexity and space complexity are fundamental concepts in general. So we'll start with some easy questions and go to a little bit of medium problems. You'll not see a lot of hard problems today because we'll encounter that in the future sessions. Cool. So let's get started with the first question. Again, this is an MSQ. Let's try to focus on solving the questions now. We will answer your general questions at the end once we finish these 5 questions today. As usual, we spend some time there, so don't worry. Let's focus on solving the questions, please, because everybody is doing it, and most of the students are here to solve these 5 questions. It's an MSQ. Again, I've written it in like clear highlighting. It's an MSQ. This is a easy question by GATE standards. I have seen so many of you who were in a hurry, who were in a hurry to put an answer, who got it incorrectly. Please update your answer. This is a very easy question. You can solve it in 30 seconds if you're careful. I've seen a lot of people who gave an incorrect answer at the very outset. Okay, let me answer this. So if you observe this simple for loop in a for loop, when I equals to 0, what do you have? When I equals to 0, the J loop will run 0 times. When I equals to 1, the J loop will run 1 times. When I equals to 2, the J loop will run 2 times, and so on and so forth. The largest value of I will be n minus 1. So when I equals to n minus 1, this loop will run n minus 1 times. So the number of times this statement would get executed is a summation of all of them. So if you sum up 0 plus 1 plus so on till n minus 1, it is simply n minus 1 into n by 2. And this is tightly bounded by n square. So a lot of people might just say, hey, A is the answer, which is true. Again, theta is a tight bounding, right? So this is tightly bounded both up and from top and below. So bounding can happen from top, bounding can also happen from below, right? So for this function, for this f of n, it's a tight bounding of theta of n squared. So a lot of people will just pick A and leave. But please read the questions, especially when you have MSQs. This is an easy question with a little bit of trickiness, little tricky. Okay, and a lot of people in a hurry of the examination will make that mistake. So if something is theta of n square, it means it's order of n square and omega of n square. It's both upper bounded and lower bounded by n square. It cannot be theta of n, but it can be big O of n cube. It can be upper bounded, something which is order of n square, or something which is theta n square. So if this is your fn, right? Your fn is less than some constant times n square for all n greater than equal to some n0. There exists, right? There exists some c which satisfies this, which means there also will exist some constant multiplied by n cube, which can be an upper bound on this, right? So your n cube can be an upper bound. Your n cube, remember, your n cube is an upper bound on c into n square. So c is also a valid option. Remember, this sort of little trickiness can be added because of the notation of theta, omega and big O. So if you have a question like this, especially in MSQ, you have to be careful to look at all the options. Please don't ignore any option. And remember that this is a tight bound, this is a lower bound, and this is an upper bound. A tight bound basically means you're both lower bounded and, you're being upper bounded and lower bounded for any given function f of n. That's it. It's a very simple question. If you just know that, something which is theta of n square can be upper bounded by n cube, that's it. You've got the answer. Many of you got it. Some of you actually gave B as the answer because they probably got confused between upper bounding and lower bounding a little, right? So A and C is the right answer. Easy question, fairly easy peasy, like 1 mark question, okay? If you're careful, you'll easily get it. Cool. So let's take the next question here. This is also an MSQ, please be careful. Again, we have explained why C is the right option in the previous question. If you do not know, if you do not understand it even after the explanation, you should learn what is big O, what is theta, what is the mathematical definition behind it. Because of constraints of time, we will not be able to go explain the whole concept here. This is an interesting question. Again, if you're not sure, please work out the math carefully for this question. Again, it's an MSQ. We have clearly highlighted it. It's an MSQ. So please be careful. It is a thought process which is important. Don't be in a hurry. I see some of you making mistakes already. So don't be in a hurry. Work out the math carefully. It is not speed, it is accuracy that matters more often. I see a lot of you making a mistake. A lot of you actually, surprisingly. Please write the math and work it out. Please, it's an MSQ, so multiple options can be correct. Please revisit your answers. While there are some correct answers, I also see a lot of incorrect ones. So please, don't be in a hurry, work out the math. If you know the fundamentals, this is straightforward. You don't have to remember anything for this. I think, just by glancing at the answers, I see more than 50% of you putting in a wrong answer. This is a good 2-mark question, folks, in GATE. This would be considered as a medium level, not tricky, but medium level. Okay, I'll wait for a few more seconds for some of you to correct, and then I'll jump into the solution. Okay, I think some of you, okay, let's solve it, right? Let's solve it. I see your answers, but there is a lot of incorrectness here. Okay, so let's go through each of the options. So you have 4 power n equals to big O 3 power n. So what does it mean? It means 4 power n should be less than equal to some constant times 3 power n, right? For all n greater than equal to 0. This is an upper bounding, right? That's what it means. It means that this function will upper bound this. That's what we are saying, right? This is the definition of what big O means. So what does it mean now? So let's take log on both sides, right? So if you take, or let's get the 3 on this side. So you can say 4 by 3 power n less than equal to c. So if you take the log on both sides, it is n into some log 4 by 3 is less than equal to log c. Again, work out the math. That's what I was trying to tell you. So n less than equal to some log c by log 4 by 3, right? For all n greater than equal to n0. Is it even possible? Right? If you think about it, this c has to be some constant that you pick. So the definition says there exists some constant c and n0 such that c into this is greater than equal to this is greater than equal to 4 power n for all n like this, right? But here, if you observe the same inequality, I've just taken a log and simplified it. So remember, for any constant c, even for a very large constant c that you will take, this whole thing is a constant because this denominator is a constant. For any large constant, this is just a constant. So how can you say that a constant will be greater than equal to n for any n greater than equal to n0? Imagine if for any constant, suppose you pick some constant here, I can pick a larger value of n here. So this will not be true. So this will not be true. This will not be true, which means this option cannot be true, right? Simple concept here. Again, we have explained this with the same logic, same approach in our course videos also. And you just have to work out the math. That's it. So A can't be the answer. So let's go to B now. Okay, this is where I think a lot of confusion is there amongst the learners. Some people think B is the answer. Some people think it's not the answer. So let's write it down. Again, always write down the math. Okay, so log 4 power n is less than equal to some constant times log 3 power n, right? And there exists some constant c and n0 such that this is true for all n greater than equal to n0. Right? This is a mathematical formulation. If you know the graph, writing this math is trivial. Okay, so now let's work it out. So what is log 4 power n? So log 4 power n is n log 4, right? So similarly, there is a constant here. Log 3 power n is n log 3. Right? So simple. So now what do you have? So you can cancel n on both sides because n will never be 0, and because this has to only hold for a large enough n. So cancel n on both sides. Then what do you have? You have log 4 by log 3 is less than equal to c. So if you observe, you can find a c because this is a constant, right? You just have to pick a constant which is larger than this. Then you can make the whole thing hold. Simple logic, right? So it is possible to find a constant which satisfies this condition, which means this is valid, which means this is valid, which means this will be valid. Again, I'm taking a few shortcuts. I'm not explaining it like very, very mathematically rigorously in the interest of time, but this is the thought process here. Again, if you want rigorous mathematical derivation step by step, finding n0, finding c, please check out some of our free videos in the course. But yeah, this is the logic here. So B is the right option without doubt. A is not. Now let's go to option C. Let's see what does option C has to do. So your option C is log base 7n is, okay, it says order of, okay, so let's write it down. Some constant, this is log 2n, right? for all n greater than equal to n0 and there exists c comma n0. This is the definition. Now if you see, log like this can be rewritten as log base 2n by log 7 base 2. This is something that we learned probably in our high school days, right? Log with any base can be converted into log of any other base by doing this. So this is less than equal to c log 2n. Now if you observe, again, for a large enough n, I can just ignore this log n and log n this side, and all I need is, I just need my c to be larger than 1 by log 7 base 2. And log 7 base 2 is a constant. So I can always find a constant that is larger than this. Since I can find it, this is true, and I can find a c, hence c is a correct option. So B and C are correct options. Now let's go to D. A is not. Again, I'm just going step by step. In the examination, you can actually derive all this in like 10 seconds if you're careful. Right? So log n square. So let's go to option D now. So you have log n square on one side, less than equal to some constant times log n cube. Again, for all n greater than equal to n0. Again, you don't have to write it. I'm writing it for completeness sake, but you can ignore that in an examination. So what will this be? It will be 2 log n less than equal to constant into n into log n. So for large enough n, you can ignore both sides. And all you need is, this is 3, right? I'm sorry, my bad. This is 3. Otherwise, the math won't work. Okay, so 3 into log n. So all you need is this constant to be greater than 2 by 3 for the whole thing to work, which means this is possible, this is possible, this is possible. So B, C, D is the correct answer. Again, this whole thing in an actual examination setup, you can actually solve this in like no time. Okay. Again, somebody says log is an unreliable technique, but I don't see any problem. If you're careful with logarithms, this is fairly straightforward. Just make sure you're not dividing by 0 on both sides. And that's not a problem here because n, you can assume that n is a large enough number and n is not 1, making both sides 0 and division by 0 problems. So log is a fairly reliable strategy. If you're careful, of course, you have to be very, very careful, right? So very simple strategy, fairly straightforward strategy, and this problem is also fairly easy, right? If you think about it, this whole thing, when I solved the question, I think I took about less than 1 minute to solve it. And for a 2-mark question, again, remember, I don't practice gate problems every day. I just know the fundamental concepts, and I often forget a lot of concepts and they derive from first principles like this. So if you're just careful with it, I think you can solve it in like 1, maybe 1.5 minutes, and it's good. 2 marks, free marks, because it's an MSQ where you have to go through each of the options. Most likely the examiners will give it for 2 marks. So this is a medium level question where I've seen people have done mistake, but you have to be careful here. That's all. Okay. Sorry, there is a problem. I think in this video we have shown for this also, right? Log 4 power n and log 3 power n. Remember, the logarithm is what makes these things. Even though you have an exponent here, it is a log which will slow it down if you want to think about it intuitively. In this case, there is no log here. So always, that's why, instead of just pure intuition, it is better to use the math. I think I've shown it here, right? It is better to follow the math concepts here. Because if you think, if you want to think intuitively, right? The exponentiation and logarithm sort of cancel out each other. Of course, it's not the same base. But in a order complexity notation, they typically tend to cancel out. But if you're not careful with that, if you don't want to do that, if you want to be double, triple careful, just follow these steps. Just write the definition, see if you can find a C and N0 that satisfy this. That's a much more reliable technique in general, okay? Cool. Again, there can be trickier options. We have not given a trickier question in this. It's fairly straightforward. I think only option B could be considered a little tricky, okay? Cool, sounds good. Okay, let's go here. Straightforward question. Yes, log is a monotonic function. Again, some of our mentors are trying to answer follow-up questions. By gate standards, this would be considered an easy, typically a 1-mark question. This is not an MSQ. I think some of you are confused. This is not an MSQ. This is an MCQ. If something is an MCQ, always pick up the best option. Remember, we did not say it's an MSQ. Please note that this is an MCQ. Hence, you should always pick the best option amongst all the 4. As some of you rightly guessed, the objective of this question is to refresh your knowledge of Master's theorem or extended Master's theorem. This is an easy question, by the way, by gate standards, because they assume that you know Master's theorem or variations of Master's theorem. Okay, I'll wait for a little more time and answer it since this is an easy question. Okay, I'm happy that most of you got it right and happy that most of you have revised Master Theorem. So this is the extended form of Master Theorem, very useful. It'll be good if you can remember it. It's actually fairly simple I'm not very good at remembering things, but Master Theorem is something that's not very hard to remember if you just practice it a little and revise it a little. So what we have is Tn equals to 3 by 2 Tn by 4 plus n square, right? This is what we have. Let's try to fit it into this format that we have. The format that we have is a t n by b. So this is your a, right? So this is your b plus some theta. So this will anyway be theta of n square, right? So n square, there has to be a log term here. So log n, but it's power 0 because this is 1, right? So you have log n with a power 0. So which means p, so p will be equals to this, right? And just make sure that it satisfies these conditions, that a is greater than equal to 1, b is strictly greater than 1, and what is our k? This is our k, right? So this is our k. So our k is greater than equal to 0 and p is a real number. It satisfies all the conditions so that we can apply it now. So in extended Master Theorem, all you have to compare is a versus b power k. What is our a? Our a is 3 by 2. What is our b power k? B is 4, k is 2, right? So it is 4 squared, which is equals to 16. So a is less than b power k. A is strictly less than. It's not equal to, it's not greater than. So we fall into this case. Within this case, there are again 2 subcases that we have to be careful with. Again, the first subcase is p greater than equal to 0, right? But p equals to 0. So we will fall into this subcase. If this is the subcase, our time complexity will be theta of nk. K is 2, so n square log p is 0. So this will be equal to 1 because p equals to 0. So the answer is theta n square, right? So if the answer is theta n square, let's look at all the 4 options that we have. We have theta n square, which is a tight bound, right? So this is the most appropriate answer. But some of you may say, hey, something that is growing at a quadratic time complexity will be lower bounded by something like a linear or a polylogarithmic function. These are called polylogarithmic functions, right? Yes, that's true. But this is not an MCQ. Sorry, this is not an MSQ. This is an MCQ. In MCQ in GATE, again, people can argue that there are other options. It's most important to say, again, in GATE, they also sometimes mention, sometimes they don't. They say please pick up the most appropriate answer. So if you have to pick one option, your option will be theta of n square and not the others. Okay, I hope this is clear. Straightforward question. If you know extended master theorem, this is literally 1 mark question. Okay. Again, there are many variations of master theorem that you will see on the internet. I think we covered the regular master theorem and also the extended master theorem in our course. This is the one that is most useful in general for gate context, because it also has, look at this, it has a polynomial as well as a logarithmic term here. So most of the stuff that you have, you will be able to think through it. Okay, fairly straightforward. Okay, here is a slightly, it's more like a worded problem, so please read it carefully. Again, somebody is asking, should we remember the standard master theorem or the extended one? Any one of them is okay. I tend to prefer extended master theorem because it handles more cases. Because it has a logarithmic term along with a polynomial term. Yeah, as our mentors are also putting it there, the extended master theorem version that we have shown is a more useful thing in the gate exam. Actually, proving this extended master theorem is far more fun. It's very hard. It takes time. It takes a lot of time, but it's a good exercise in general. Like, this is something that I did during my master's days. Again, please read this question very carefully. This is a slightly worded question. Try to understand it and pick the best option. Look at this. Here we clearly mentioned that pick the best option below. Please read it carefully. This question is all about reading it carefully. It's an MCQ, it's not an MSQ. This sort of questions could be asked in GATE with about 2 marks. I think similar questions have been asked in GATE earlier, and we see many of these types of questions in top university assignments and midterm and semester end exams. I see in the chat window various answers. Let's see what, maybe I have missed something, but let's solve it together. I see A, B, D. Okay. Let's wait for a few more seconds for all those who are trying to put in their answers, and then I'll dive into the solution. Okay, so let's go into the problem itself. A recursive algorithm on numbers. So this is an algorithm which is operating on numbers, is designed in such a way that it is divided into 3 subproblems of size in the ratio 2:3:5. So if I have a problem of size n, I'm dividing it into 2:3:5, which means this will be 2n by 10, first subproblem. The second subproblem is 3n by 10, and the third subproblem is 5n by 10, because these 3 numbers will sum up to n, and this is the ratio they are in, 2:3:5. Simple ratios, right? And what happens after that? A non-comparison based numerical sorting. So this will again, because if you have a problem like this will again get subdivided into 2 by 10 into 2n by 10, 3 by 10 into 2n by 10, 5 by 10 into 2n by 10, right? So it will keep getting divided like this, right? Recursively it will keep getting divided. Now the interesting aspect here is it's saying a non-comparison based numerical sorting algorithm. So typically in merge sort, what do? We do comparison sorting, right? But what is being used here? A non-comparison based numerical sorting algorithm to merge the results. So whatever results I get here, I'm going to merge it and get it to the top, but I'm going to use a non-comparison sorting, all right? So which means I will not be doing something like what we do in merge operation in a typical merge sort, because that is comparison based sorting, right? So non-comparison based sorting. Okay. Note that the results obtained recursively, which means when I break it into smaller regions, fall into a very small numerical range. So whatever results that I get, suppose if I get an array here of this size, an array here, an array here, the values that are there here are very small. They're not very large. They're not like 100 digits or 1000 digits or anything like that. They fall in a small numerical range, and I can ignore the number of digits. Like for example, here if I have 123, the number of digits is ignored. You can ignore this as compared to n. That's what this statement is saying. Now, which of the following describes the time complexity of such an algorithm? Pick the best one below. So let's go into it. So suppose you have an array here, a numerical array of size 2n by 10, size 3n by 10, and size 5n by 10. You have to merge it using non-comparison sorting. If you have to merge it using non-comparison sorting, you can use sorts. You can do something like radix sorting, right? Which is a very popular non-comparison based sorting. What is the time complexity of radix sort? How many elements are there? There are total n elements here, right? 2n plus 3n plus 5n by 10 will be n elements. So to sort or to compare or to sort these n elements using radix sort, it will be order of n into d, where d is the number of digits that you have, maximum number of digits in any number. But it says those numbers fall in a very small numerical range which can be ignored, which means I can ignore the d here, right? So whatever solution I get here, to merge it and get to the bigger solution, I'm going to take order of n time, or to be more precise, theta of n time, right? Some theta of n time. Now at each level we know, okay, so now let's go and think through a little more. Okay, so I'll just erase this a little and let me put in the numbers. Okay, so at this level the amount of time we'll take is some constant into n. What about the time that we'll take in this level? So if you add up all these and apply again radix sort, ignoring the number of digits, this will be 2n by 10, because the total number of values that are here will be 2n by 10. Here it will be 3n by 10, it will be 5n by 10. The sum of all of this will be again some constant into n, right? Now the only thing that you have to care about is what is the depth of this tree. Again, remember you have a 2 by 10, 3 by 10, 5 by 10. So this will be some log n. Again, we don't have to care about the base because it will be some order of some constant, let's say alpha into log n, some constant times. So the depth of this recursive tree is some constant into log n. The cost at each level is some constant into n. So if you sum up all of this, you will get some constant c dash into n log n, right? So the time complexity will be theta n log n. So B is the most appropriate choice here, right? Simple, that's all. It's fairly straightforward, right? Now the depth will be logarithmic. The depth will not be 2 by 10, because at every stage, so if you think about it, I think, so if you have n here, right, you have 2n by 10 here. In the left subtree, you have 2 by 10 squared n, then 2 by 10 cubed n, so on and so forth. So if you see the length of this left subtree, this itself, this will be the longest, and it will be some constant times log n. Again, we have derived this in the course videos when we do, again, I believe these are publicly available. We actually use the tree-based method to compute time complexity, where we actually work out these details and show that the depth of this tree will be log n with some base. right? It will be some base alpha, but this I can look at it as, in terms of time complexity, this I can think of as theta of log n, right, with base 2 also, because this will be some base, but I don't care about the base in time complexity as much, right? So technically speaking, this will work, right? Simple logic. Okay, cool. So this is a straightforward question. Again, it's slightly worded differently. I think some of you felt that the answer is none of the above. I'm not sure why. Probably you got confused with the depth of the tree or some of those variations. But whenever you have a problem like this, just try to draw the tree, right? Just draw the tree. Again, what is being tested here is, imagine if you're given a problem where we change it slightly, right? What have we changed here? In merge sort, we have like a constant into n time here, but we are saying we'll use a non-comparison sort. So we are mixing some concepts from non-comparison sorting like radix sort to a tree-based method for computing time complexity. It's just a small addition. This is typically like a 2-mark question considered medium level at gate standard. Okay, so here comes the last question now. So there is an answer to this. Please fill in the answer, and then we'll have a follow-up discussion on which of these techniques is better and why. This is more of an interview type question. It's a good interview question at product-based companies. So we will touch this a little later. First, let's answer the numerical question. Again, in time complexity, the base of the logarithm, you don't have to worry too much because it will anyway get subsumed and consumed in the big O or theta notations. We will discuss the follow-up little later, but let's answer the first part of the question here. Please read the question carefully. This is also a very interesting question format that we have seen at some of the top universities in terms of their assignments or midterm or semester end exams. Again, just in GATE, typically what happens is for numerical type questions, they might say round it to the nearest integer, round to the nearest integer, let's say. That will simplify the question. Round it to the nearest integer. Okay, let's assume that is mentioned just for clarity here. Let's assume that is mentioned. Okay. Again, they typically tell you round it to 2 decimal places or 1 decimal places. Let's assume they say round it to the nearest integer. Because there are a lot of assumptions that we're making here, like identical conditions, identical constants, and things like that. Okay, I see literally a varied spectrum of answers. Let's see how this works. Again, feel free to use a calculator if that helps you. Okay, let's wait for a few more seconds. I believe some of you are still solving it. After that, we'll have a very interesting discussion and a follow-up to this question. Okay, so let's try to solve it together again. So we have 10 million products. So the n equals to 10 million. 10 million is 10 power 7, right? That's the number of products we have. And each product code is 16 numerical digits, right? And the merge sort takes 23.35 these are what, microseconds, right? So, so the number of digits equals to 16. Merge sort time complexity is theta of n log n. Right, so this is merge sort time complexity. So let's assume what we have is some constant into n log n. Right? That's what this means, right? That's what this implies. This implies that the time complexity is some constant into n log n. Now, so some constant into n log n is 23.35 microseconds. Right? We already have n. We just have to find the constant because the question says assume identical conditions and constants for both sorting functions. So we have to find the constant now. So the constant into 10 power 7 into log base 2, right? 10 power 7 here, right? So what would this be? This will be 23.35. So if you take log 10 power 7 base 2, let's actually do it on Google Calculator just to be sure. I hope I've not done, how do I do log? LG 10 power 7. Sorry, my bad. I think LG will give log base 2. Okay, log. This gives me, sorry, my bad. Log 10. Okay, log 10 power 7. No, this is base 10. So I need, yeah. So if you do log LG in Google Calculator, you can do this. On the regular calculator also, in scientific calculator, you have this. This is 23.25, right? So approximated, of course. You can be more precise here, but approximately 23.25. So what do we have here? So this is 23. So this will be 23.25, or else you can also do it differently, right? You can say log 10 power 7 base 10 by log 2, right? You can do this also. This is another way to do it, right? Simple math. Or else if you have a scientific calculator that computes log 2, you can also do it this way. So 23.35 or 25, I'm sorry, 23.25. Okay, so roughly some numerical value around 1. Again, since it says round to the nearest integer, if you just work out the math, so this number and this number are very close to each other. So this constant now, I mean, this will be some 1 point something, right? 1 point some small value. So 23.35. So let me just do it. 23.35 divided by 23.35 divided. My bad. Come on. What's happened to my typing? 23.35 divided by 23.25. Again, you can do it, I'm sure. So 1.004. Let's just round it to 1, just to make our math simple, because anyway, we're going to round everything to the nearest integer. So we can just cancel these two, have 1 here. I'm just simplifying everything. But if you're careful, if you need more, like if you need 2 decimal places, etc., you have to be more careful. So then what will C be? So you can just cancel this whole thing. C will be 10 power minus 7, right? So C will be 10 power minus 7. And if C is 10 power minus 7, what do we have? We want to use a radix sort. What is the time complexity of radix sort? It is theta of n into d, where d is the number of digits and d equals to 16. So this implies this is some constant into n into d. But we said all the constants for both sorting are same, right? So we'll just use the same constant here, which is 10 power minus 7. And n is 10 power 7 and d is 16, right? Because you have 16 digits, right? So the total time complexity comes to about 16 microseconds. So if you have to round it to the nearest integer, 16 will work, right? Of course, you have to be careful with the rounding, but this is straightforward, right? Very straightforward, simple solution. Now, what is more interesting here is, imagine if you're an actual engineer working on a real problem like this, right? Now, if you're solving a real problem with 10 million products, 16-digit product code, will you use, again, we see that the merge sort takes about 23.35 microseconds. and you know that your radix was taking about approximately 16 microseconds. Which one will you use in the real world? Again, this is going to be a very interesting discussion. So let's discuss this. Any thoughts you guys have on this? The question is clear, right? For this specific problem with 10 million products, we see that radix is taking less time. So should we just go for radix? If so, why? If not, why? Let's think about that. Okay, let me see your questions. Okay. Again, there are two questions. Good point, Pratik. We had questions on radix sort because we did not ask enough questions in the earlier live sessions, right? We're trying to cover everything. So somebody says, okay, space complexity depend on the memory. Very nice. But I have one question for you. We're thinking in the right direction, right? So what is the space complexity of radix sort, right? The space complexity of radix sort is theta of n plus d, right? And d is very small. D is just 16. That's just 16 variables there, right? So it's not actually significantly different from the regular merge sort, which is theta of n, right? For the merge sort, what is the space complexity? It's theta of n. For the radix sort, it is theta of n plus d, where d is the number of digits, and number of digits is just 16. So why do we have to really worry about it, right? Somebody is saying about space, right? Because of very high utilization of RAM. No, Ayush, no. The time complexities are very the space complexities are very comparable. One is theta of n, the other is theta of n plus d, where d is just 16. So the regular merge sort and radix sort are roughly the same in terms of actual space complexity. No, Ayush, I don't think it's n plus 2 power d space complexity. Let me just show you that. No, if I'm thinking correctly, I don't think, let's just go to radix sort Wikipedia, because Wikipedia has all of this data anyway. Look at this. It says, okay, let me just zoom it in a little. So radix sort time complexity is order of w plus n. What is w here? W is the key length, which is 16 in our case. This is worst case space complexity. Worst case time complexity is w into n. We know that. So here is w here is like our d, n is the same. So it's not actually 2 power, it's not actually 2 power d that as you mentioned, right? So the question here is, given this setup, given this specific question, which is better? Is merge sort better or radix sort better? Okay, some of you are going in a right direction, like Shiva and Shaikat are saying, hey, merge sort, I can do it, I can do external merge sort if all the data doesn't fit into RAM, right? You have 10 million records. Each record is, let's just do the back of the envelope calculation, right? 16 digits, right? So each digit, let's assume it's just a single character. So that's about 16 bytes. So 16 bytes into 10 million records, that's about 160 MB, not too large, it will fit into memory, right? It will fit into memory, right? So, I mean, 4 GB RAM is fairly common, so we don't have to worry so much about memory as some of you have gone too deep into memory, mixing up the space complexities of radix and merge, but you can fit the whole data into RAM, right? 16 digits, right? 16 digits for every number. So if you store it using characters, 16 bytes into this, I mean, you can do it fairly quickly. Okay, let me see others. Due to excessive recursive calls, we can use radix sort. You can implement merge sort fairly beautifully without getting too caught up into the recursion part. Like every recursive algorithm, you can write a non-recursive version of it, right? Again, something that we discuss in the course. Somebody says radix sort will be used because overall it's better. Why is it better? That's the question. Think of it as an interview discussion, right? Why is it better? Somebody says overflow in radix sort. Why will you have overflow in radix sort? You know that every product number is 16 digits. It's fixed. Memory is not a concern because the space complexity is roughly the same. You can fit the whole data into your RAM. I'm looking for your thoughts. So somebody says radix sort can only be used on numeric based data. No, you can do it on strings also, because you can compare one. You can do alphabetic sorting using radix sort. Nobody says you can't. You can. And we already say that it's a 16-digit product code. Somebody says it's easy to code, but most of these you'll get really, really optimized implementations in C++ or Java or Python. So you don't have to worry about good implementations. You get it readily available very often. Again, I'm just opening up the discussion here just to see your thought process. So if I were to pick a solution, because all the data fits into RAM and radix sort will typically run faster. Of course, here the fundamental assumption that we have made is the constants are the same, but the constants may not be the same when you actually write code. It depends on lot of internal details, right? But within the limited scope of what we know from the question, I would pick radix sort right now because space is roughly the same. The whole data can fit into RAM, which means I don't have to do external merge sort. And if all the constants are the same, radix sort is roughly what? It's 23 seconds versus 16 seconds. That's about 7 out of 23. Roughly about 28-30% faster. Why not? Do it. But if the size of my data increases and if I can't fit into RAM, external merge sort is a better strategy, right? So again, all these are, these types of questions are helpful because it will force you to think in terms of actual RAM that is occupied. Does it fit? You have to think through from that perspective, right? Okay, folks, with that question out of the way, let's do the general Q&A. So the table is open. Feel free to ask general questions. I'll try to answer as many as possible. Let me just pull up my phone here. Cool. Varun, you're right. You're right. Again, if somebody has a problem with watching the videos on a mobile device, just reach out to us. One of our engineers will help you remotely. So don't worry about that. That's a minor glitch. You might have to just refresh your cookies and things like that. It'll work. So Akriti asks, how much time should one devote to coding to manage it along gate preparation? It all depends on how much time you have before your placements. But ideally, before your placements, try and code up at least 150 to 200 problems. Depending on the companies that you're targeting, you might want to do medium or hard or easy questions. But writing actual code for about 150 problems will give you both the confidence and the comfort with the language in which you're coding. You can code in any language, C, C++, Java, Python, JavaScript, doesn't matter. But write the code, get the output. So I would put the minimum number as about 150 because that's when you start getting confidence and comfort. So try and write, again, if you have 3 months for it, okay, very good, write 1 to 2 problems a day. If it's easy problems, code for 2 problems. If it's a medium or a harder problem, do 1 problem a day. It all depends on how you pace things. So Manoj says, any suggestions for working professionals? It's the same like anybody else. You just make sure that before you go to work, you spend a couple of hours. After you come back, spend about 1.5 hours revising everything. It's just that unlike a student, you can't take major breaks in between your work, but the process is the same. Try and put in at least 2 hours before you start the work. Learn the core concepts then. Evenings you can revise or take tests and things like that. Somebody's talking about negative product codes. Product codes are like 16-digit numbers, right? So no negative numbers there. How to be consistent? I think that is one of the hard things. So we have videos on our YouTube channel on how to be consistent. There is actually a video titled "How to be consistent and persistent in your gate prep," where we discuss multiple strategies. But I mean, these are actually very well known, studied from psychology research, a lot of experimentation behind them. But try to fix times. Say, hey, in this time, this is what I would do. Okay. If you can slot your day carefully with breaks in between and say, in this time, I'm not looking at my phone, I'm not looking at my laptop, or I'm not looking at all the distractions. I will focus, sit and study without, try to squeeze those 90-minute windows. it'll all add up a lot. Like on first day, you may not see a huge impact, but once you do it for a few weeks, like 3-4 weeks down the line, you'll see a lot of impact. So somebody struggling with linear algebra. Linear algebra is fairly simple, right, in GATE. If you know the basic equations, if you know the basic formulations, linear algebra is just applying that to the real world problem. Again, I think most of our linear algebra content is publicly available on our website and also our YouTube channel. So please check it out. We try to give some geometric intuition, especially coming from machine learning backgrounds. We have that geometric intuition because that's how we see linear algebra and use linear algebra. So check that out. It might be helpful for you. It'll become easier to digest, especially some of the complex ideas. So Pranav says, I'm scoring 60 marks in practice tests. That's very good. That's you're doing good actually. How to score more? Simple. Debug all the mistakes you have done. All the 40% marks that you're losing, don't check the answers right away. Give it a couple of hours break. Maybe if you've taken the test today evening, just solve those 40% incorrect questions tomorrow morning, right? Give it some few hours between this. Most likely you'll be able to solve more correctly in the second iteration. Even after that, if you're not able to solve, just debug. See if you have a conceptual gap, or if you've done a silly mistake. That happens a lot. So you can easily go from 60 to 80, even 85 by just reattempting the questions where you got incorrectly and covering for your silly mistakes. Of course, there might be 10-15% of conceptual gaps that you have to go back and watch the videos or look at similar solved problems. This is a very nice question. Why can't we cache in sorting algorithms? Actually, there is a whole area in computer science or algorithms, I should say. It's called cache-aware algorithms. Just like out of memory algorithms, where we use disk and network and all of that, there is a whole area called cache-aware algorithms. There are sorting algorithms that are cache-aware. It is typically studied at a graduate level or at a PhD level. I think some of that, I'm not sure. I don't think they're actively there even in Cornell-Leeserson because it's slightly above that level. But if you want to look at cache-aware algorithms, just go to MIT OCW. This is Massachusetts Institute of Technology's open courseware. They have a course, I don't recall the name of the course, probably their introduction to algorithms itself. I think the last lecture they talk about cache-aware algorithms. This is at graduate level. I think because the professor worked on that topic, right? So just look at that. So there is a whole area called cache-aware algorithms, which are actually used, by the way. I'm not saying they're not used. They're very important when you have large amounts of numerical processing and some mathematical libraries and numerical computation libraries and machine learning libraries actually use cache extensively to speed up operations. So you can use them. Yes, that's a nice question. How to master combinatorics and probability? Lankesh, a lot of people have the problem with combinatorics and probability. The way to look at that is, when you're asked a question, a lot of students make this mistake that they try to remember formulae for combinatorics and probability. To be honest with you, even if I have to think of Bayes' theorem, I think from first principles because I'm very bad at remembering things. I'm like probably one of the worst guys you have seen who can't remember things easily. Like I even forget names of people very easily. I mix up names. So I'm terrible, really, really terrible. I will rate myself 2 out of 10 in terms of memory. So what I do oftentimes is I try to solve it from first principles. I try to draw diagrams when I'm counting. I say if there are 4 positions or if there are 4 positions in a circle, I try to think, okay, how many can I place here? How many can I place here? Again, this is very similar to how we try to teach in the course also. Even concepts like Bayes' theorem, probability distributions, I try to think of them from first principles, like, okay, Gaussian distribution. There are some that you have to remember. For example, PDF of a Gaussian distribution, you have to know the formulation because deriving it from first principles is fairly non-trivial. But things like Bayes' theorem, the best way to learn these and solve problems is to go to the very core of it, try to solve problems from first principles with diagrams. That's what I often do. That works phenomenally well. That's what I've done over the last 15 or so years since I've started learning probability and statistics and also combinatorics. So Jashwant says, any shortcuts for minimization of DFA? Again, the problem, you can use intuition and try to do some minimization, But let me tell you, I think in one of our live sessions for minimization of DFA, or converting a recursive, converting a regular expression to DFA, one of those problems, I tried to use too much intuition and I made mistakes. I actually made a silly mistake in one of the live sessions where I was thinking something and students corrected me. I was very happy with it. So my takeaway that day, which I still remember, is it's better to follow the simpler methods, the straightforward methods, than apply too much intuition, because the question could be given in a slightly tricky fashion where if you think too intuitively, you can fall into a trap. The best thing about theory of computation, except for undecidability, is everything has a step-by-step process. You just follow the step-by-step process, practice, you'll get 90% marks. Undecidability is a little tricky. Except that topic, everything else is step-by-step process. So Ayush says gate set slightly harder questions for combinatorics and probability. I won't say hard questions, because if I have to say that, right, because most of the combinatorics and even some probability questions in gate are actually easier than IIT JEE. I mean, let's be honest here. They're actually easier. Even gate questions are easier than CAT questions in combinatorics or basic probability. So I wouldn't call them hard per se, because they're actually not hard. They may be relatively hard as compared to other topics, but they're also, I mean, if you practice a little, I think you can easily score good marks in it. But we see students scoring less marks because they've had that fear of combinatorics from their 11th and 12th, and that has been haunting them all through this life, right, or till date. So somebody says, why is cache limited? Why is it 6 MB and not 600 MB? Again, cache is very expensive because cache has to be placed typically in this on the CPU. Right? Typically, some cache is actually physically there on the CPU chip itself. And manufacturing a CPU chip is probably one of the greatest engineering feats of modern science and tech. So as the size of the chip increases, as you keep placing more and more memory, it becomes harder to manufacture, and it will also become hotter and hotter. Again, I'm not an expert in VLSI design or chip design, but from a limited understanding of chip design, this is what I see. Again, one great example is how Apple makes their Apple Silicon M1 chips. So they have cache and all that stuff, but they try to put the actual RAM, they call it integrated RAM if I'm not wrong, where they place the RAM itself on the single SoC where there is a standard microprocessor, of course ARM-based microprocessor, and also your GPUs and specialized processors. That itself is a non-trivial, very complex engineering challenge. I think there are literally maybe 1 or 2 companies in the world which can do it today. So it's actually an engineering hurdle, more from a VLSI design and manufacturing, and not that they don't want to do it. Everybody wants more cache, but it's just so expensive and so hard to do it. How to manage good projects along with GATE, PGE, because IIT H interview, they ask about projects. Again, when you go to Triple IT Hyderabad's PGE interview, whatever projects you have done in your BTech third year or final year, I mean, that would be good, because look at your competition. Your competition is very similar to you. I think they give a lot of importance, even in the interviews. There is some importance given to projects, but more importance to the examination that you have written and the interview questions they ask you in an actual interview setup, with multiple professors asking you questions on different areas that you consider yourself to be good at. I think that's what has the highest weightage. If you don't have too much good projects, it's okay, because doing them will take time for you, right? This is from Harsh. Harsh says, diagrammatic approach will eventually get us to the answer, but how to practice this under time bound or question? Harsh, the diagrammatic approaches are not just for practicing now. I mean, you can easily use them in the examination. So don't worry too much about the speed right now. Once you solve, like if you're a course enrolled student, right, you will solve like 5,000 to 6,000 questions as part of practice test series 2021, test series 2022, etc. If you solve all of that with time, right, you'll become very, 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 very fast at it, right? So don't worry too much about time right now, because if you find that it's taking too much time going through the diagrammatic approach, it takes the same time for others also, but you have a higher chance of getting more marks because you're doing lesser mistakes. Again, don't try to get 100 of 100 in GATE because nobody gets it realistically. Even the professors who set this question paper, if they all attempt the question paper with some randomization, they themselves won't get 100 of 100, realistically speaking, right? If you're in the 70 plus bracket, you're in a very safe zone. So its speed is less important as compared to accuracy. So try to get into that accuracy zone, high accuracy zone with more practice. Practice has to be there. There is no escaping that fact. Cool. Rakesh says how to stop comparing ourselves with others. Just stop it. I mean, just ask yourself. I mean, one thing that I often do is I say, hey, where was I 1 month back? Where am I now? How am I going to go? Don't compare with others. Go with an absolute number that you want to get 70 plus marks in the GATE exam. That's the baseline that you have to. Of course, if the question paper is hard, even getting 50 marks will be hard. But in general, if you're getting 70 plus marks, you're on the right track. Suppose if you're getting 40 plus marks, don't look at your friends and say, hey, that guy is getting 50 marks. Don't worry. Ask yourself, how do I go from 40 to 50, from 50 to 60, 60 to 70? Again, we have detailed videos on our YouTube channel that you can follow for that. So somebody says, I want to go to IIT Bombay. What are the estimated marks? Again, if the question paper is similar to the last couple of years, I think getting about 70, 72 plus, you're in a very safe zone to get into the top 100 ranks. I think last year was some 72 normalized marks, if I'm not wrong. So it's fairly easy to get into IITB if you're in the top 100. Fairly easy. Cool. Sounds good. I think that's all we had as questions today. That's all. I think there is one question. I'll answer this before I sign off. Why is the test series price higher, slightly higher this year than the previous year? Because for test series, unlike many other institutes and academies, we actually answer, like last year I was just mentioning it in our video, right? We answered about 11,000 questions from test series enrolled students for only test series questions. And that consumes a lot of resources, right? That consumes a lot of human time, which means, and these are people that we employ from some of the good universities of India, right? Because it costs time and resources, the price has to be adjusted accordingly. So if we say, hey, I'll just give you a question paper, nothing else, I will not answer any follow-up question, we can give it at a much lower price. But that's not our core philosophy. Our core philosophy is, if a student is tackling a question, if he or she is not understanding, even if he's a test series student, for the questions in the test series, we want to be as clear as possible, clear the doubts. Of course, we will not be able to clear the doubts in general, because that will not again scale. But at least for the questions that are there in the test series, we want to answer as clearly as possible. I don't think, to the best of my knowledge, any other institute or academy that gives you GATE prep does this. So the price has to be proportional to that. Otherwise, again, you cannot ignore economics 101, right? Without economics 101, everything will collapse. So we have to take economics 101, basic pricing logic into consideration. The whole test series is, the pricing of test series, we try to push it so low that most likely will not even break even this year for the test series. In terms of the effort, in terms of the manpower that our team puts in, we don't think we'll break even with 2,500, right? So I hope you understand. Cool. Sounds good. Okay, guys, thank you very much. I wanted to answer that specific question, and all the very best. Thank you very much. Bye-bye. Again, most importantly, please stay safe. Get vaccinated. I keep telling this every time. I do not want to forget it. I know that the test positivity rate is about 2%, but please